To understand our world, we must look through the lens of why.
Welcome to The Explainer, where we don't just scratch the surface, we peel it back. Today, we're diving into, honestly, one of the most eerie, mind-bending discoveries in all of modern science. We are going to look at the structural, mathematical, and statistical similarities between the gray matter sitting right there inside your skull and the vast cosmic scaffolding of the universe itself. And let me be clear right up front, this isn't just some poetic metaphor. By the end of today's Explainer, you're going to see exactly how fundamental physics forces matter to organize in the exact same way, whether it's microscopic brain cells or clusters of entire galaxies.
So does the human brain actually resemble the universe? Let's just dive right into this bizarre question. I mean, for decades, philosophers and sci-fi writers have joked around with the idea that the universe might be a giant brain or that our brains are little universes, but recently an astrophysicist named Franco Vazza and a neurosurgeon named Vazza-Feletti teamed up to take this question totally out of the realm of science fiction and put it under the microscope and the telescope. They wanted to see exactly how the universe organizes matter compared to how our biology organizes neurons. Now take a look at what we've got here. Notice the undeniable visual similarity. On one hand, you're looking at a simulated cosmic web. That's the large-scale structure of our universe where galaxies are born and evolve. On the other hand, you're looking at a cultured human neuronal network. Without the labels, it is literally incredibly difficult to tell which is which, right? They both feature this very distinct web-like pattern of bright nodes connected by sprawling filaments. But as you'll see, visual similarity is just the very beginning. We really need to see if the math backs it up. All right, Section 1, a mind-bending cosmic mirror. This next part completely shatters our perception of scale. To truly appreciate what we're looking at today, you have to understand the sheer size difference we're dealing with. We're talking about a staggering 27 orders of magnitude. Just to put that into perspective, that is a billion times difference in size. You've got the cosmic web stretching across billions of light years, and your brain's neural network operating on the tiny scale of micrometers. And this is the wild part. It brilliantly illustrates that whether you are looking at billions of light years governed by the sheer pulling force of gravity or tiny micrometers governed by biological electrochemistry, the resulting network shape is virtually the same. Scale, in this context at least, is almost an illusion. It seems nature just has a preferred architectural blueprint, and it uses it across drastically different environments. Okay, moving to Section 2, Anatomy of Two Networks. Let's look at the hard data, because this is where the statistical similarities just become impossible to ignore. When researchers actually mapped these systems, they found that the human cerebellum has roughly 69 billion neurons. The observable cosmic web, it contains over 100 billion galaxies. So, similar ballpark. But look closely at the connectivity. When they analyzed it, they found that both a neuron and a galaxy exhibit an average of precisely 3.8 to 4.1 connections to their nearest neighbors. Let that sink in. Both networks independently evolved to have the exact same level of connectivity per node. The similarities actually go even deeper when we look at mass composition. If we look at the human brain, it's not just a dense, solid ball of neurons. In fact, only about 25 to 30% of it is active tissue. The remaining 70 to 75% is just a passive material, water, which plays an indirect role in structuring the network, sure, but it doesn't actively process the signals. And startlingly, the universe mirrors this almost perfectly. When we measure the observable universe, we find that around 30% of its mass is made up of galaxies and visible matter. The other 70%? Well, it's an apparently passive, unseen material that we know as dark energy. So both the brain and the universe require this massive passive medium just to suspend and support their active networks. We can actually see this hub-and-spoke topology up close right here. Notice how galaxies cluster really densely at the exact points where cosmic filaments intersect, leaving these massive empty voids in between. This is functionally identical to how your brain wires itself. Synapses concentrate at dendritic convergence points. The activity, whether it's the intense glow of a galaxy cluster or the electrical firing of a tiny synapse, is heavily enhanced at these structural nodes. Which brings us to Section 3, the mathematical blueprint. To prove this isn't just our human brains playing pattern recognition tricks on us, the researchers subjected both the cosmic and biological networks to rigorous mathematical analysis. They really needed to see if the underlying math matched up. So they used a tool called spectral density calculation.
This is a heavy-duty technique, usually strictly reserved for cosmology, to study how matter fluctuations scatter across the entire universe. But by applying this exact same cosmological tool to form micrometer-thick slices of the human cerebellum, they could finally compare apples to apples. And wow, the data reveals that the distribution of matter in the cerebellum follows the exact same progression as the cosmic web across nearly 2 decades of spatial scales. Whether you are zooming all the way out from 5 million to 500 million light years, or zooming way in from 1 millimeter to 0.01 millimeters, the amplitude of fluctuation is practically synchronized. This synchronization tells us something profound. I mean, it is not random. Both of these massive systems are bound by strict power laws. Power laws basically dictate how a complex system grows to optimize its energy flow. If these networks just grew completely at random, they would eventually require an infinite amount of energy to sustain themselves, which, as we know, completely breaks the laws of physics.
And here is where it gets highly specific. If you compare the brain and the cosmic web to other natural systems, like clouds, tree branches, or water turbulence, they simply don't match. Clouds and trees are purely fractal, meaning they look the same at every scale infinitely. But the brain and the universe share a unique, scale-dependent self-organization. They aren't just generic natural patterns. They are a highly specific, shared architectural blueprint. Moving to Section 4, petabytes and information capacity.
Now, prepare yourselves, because scaling this up leads to a climax that is just mind-bending. Using information theory, researchers have actually estimated the memory capacity of both of these systems. Through mapping out dendritic spines and synapses, they estimate the adult human brain can hold about 2.5 petabytes of information. When cosmologists run the exact same numbers on the structural complexity of the observable universe, they find it requires roughly 4.3 to 8 petabytes to store its data. So what should you take away from this? Well, the conclusion is truly staggering. Because the information capacity is in the exact same ballpark, it means that the entire body of information stored in your head, every single memory, every skill, your entire life experience, could theoretically, mathematically speaking, be encoded directly into the cosmic scaffolding of the universe itself. Absolutely incredible.
Finally, Section 5, the physics of complexity. Now, before we go declaring the universe a giant, conscious entity that's, thinking its own thoughts, we need to ground ourselves and understand the actual physics driving this phenomenon. As neurosurgeon Vazza-Feletti points out right here, this structural convergence happens because nature is solving the exact same problem at every conceivable scale. It's a matter of fundamental physics, not necessarily consciousness. Think about it like this. Whether nature is trying to route complex information via electrochemistry inside the tight biological confines of your skull, or routing massive amounts of matter via gravity across the cold vacuum of space, it hits a hard thermodynamic limit. To prevent spending infinite energy, nature builds this exact filament node structure. It is simply the most efficient way to achieve structural criticality, basically balancing on the razor's edge between rigid order and total chaos. So the universe is probably not a literal thinking brain, but rather your brain as a flawless thermodynamic mirror of the universe's ultimate architecture. The exact same laws of physics that sculpted the massive galaxies out there sculpted the very neurons you are using to understand them right now. You are, quite literally, the universe experiencing itself through a perfectly mirrored microstructure. So, I want to leave you with this final provocative thought. If our brains are structured exactly like the cosmos to optimize information, what other universal secrets are locked away inside our own heads, just waiting to be discovered? If this exploration of reality's fractal architecture blew your mind today, be sure to hit that subscribe button for The Explainer, because we are just getting started.
Why settle for shallow facts? Join the intellectual rebellion. Subscribe to WhyLens now.